Okay, a meteorologist is modeling the height of a hot air balloon, and it's assuming it's traveling vertically upwards and travels 450 meters in the first minute. Due to the decrease in temperature as the balloon rises, the balloon will continually slow down. The model suggests that each minute the balloon will travel only 82% of the distance traveled in the previous minute. Find how high the balloon will travel in the first 10 minutes after it is launched. Okay, so the key, every question, guys, has a key, and this key is to recognize that this is a geometric sequence. In the first minute, it travels 450 meters. In the second minute, it travels 450 times 0.82, because it's 82% of what it did in the first minute. In the third minute, it travels 450 times 0.82 squared, because we get 82% of this. And it continues, and this is a geometric sequence with first term 450 and common ratio 0.82. Now I like to write out the geometric sequence, guys, and I like to write out this once you know it's a geometric sequence. So how high the balloon will travel in the first 10 minutes, it's the sum of the first 10 terms. So the sum of a geometric sequence is, let me write out the formula. It's U1, U1, or, well, actually, hang on, 1 minus r to the 10 over 1 minus r. That is the sum of a geometric sequence. And I have U1, it's 450. I have r, it's 0.82 to the 10. And I have 1 minus 0.82. So this in the calculator gives me, let's put it in, 450 times 1 minus 0.82 to the power of 10 over 1 minus 0.82. Press enter and I get 2156.38. 2156.38. Okay, which is obviously, if you want to do three significant figures, 160 meters. Okay, the balloon is required to reach a height of at least 2,520 meters. Determine whether it will reach this height. So, this, guys, so the balloon is going to keep going up. So it's going to go up and up and up. And the question is, will it reach 2,520? Now you could think, well, obviously it will, because we're going to keep increasing. But remember, this is a geometric sequence with a common ratio less than 1. So it might have a limit, and to find the limit, we need to do the sum to infinity. So if I add all these numbers up for forever, will I get to 2,520? Let's find out. So sum to infinity is U1 over 1 minus r. U1 is 450. 1 minus 0.82. And let's see what this is. 450. 450 divided by 1 minus 0.82. Obviously, that's just 0.18. 2,500. Does it reach this height? No, it doesn't reach 2520, because that's the max height it will ever reach. Finally, and you'll notice, guys, this is the second time I've read this where it suggests a limitation of the model. So they do ask this a lot, and when they ask it, you gotta think, like, use your common sense. What's a limitation of this model? Well, there are loads of limitations. Like why would it travel exactly 82%? Like that's an assumption. 82% in each minute. there's wind resistance, how many people are in the thing, like what's it taking into account. Well, I think the best one to go with, you can, I think the mark scheme gives about 10 different things you can write down, and there's probably even more that an examiner would accept, but I think we may as well stick with this one, because it says the model assumes that the balloon travels vertically upwards, but no hot air balloon will travel exactly vertically upwards. Like it'll have to move horizontally as well. So I'm gonna write that down. The model doesn't account for horizontal, or let's say, I won't say account for, but doesn't it doesn't take into account horizontal displacement, let's say. But guys, there's loads of different things you can write here for that mark. Say wind doesn't take into account that there might be wind or resistance or anything like that. Okay, that's it, guys. That is question 7, is it?